Welcome to the Explainer. Look, if you've been following the AI space at all lately, you already know that voice is absolutely the next major frontier. So today, we are completely demystifying GPT Realtime 2. We're going to look at the exact anatomy of a production-ready voice agent. Bring your focus, grab a coffee, because we're unpacking exactly how to build for this massive voice first wave. To start us off, I actually want to pose a critical question directly to all you developers and builders tuning in. What actually separates a neat, highly controlled voice demo from a rigorous, production-ready AI agent? Well, in the past, we had to rely on these traditional cascaded AI stacks, right? First, you transcribe the text, then you process it with the text model, and finally, you synthesize it all back into speech. But that sequential pipeline, it's just way too slow. It's too brittle for the rigorous demands of real-world voice. Production environments simply don't tolerate delays. They require instant, fluid, and genuinely intelligent responses. Okay, let's dive into this. We're going to build our knowledge up like a layer cake today. First, the architecture, then building assistance, handling noise, and finally, managing context. Starting off with Section 1, the foundation, the GPT Realtime 2 architecture. The absolute core innovation here is a multimodal voice-to-voice architecture. This completely eliminates the awkward pauses of those old cascaded pipelines we just talked about. Under the hood, you've actually got three distinct models working seamlessly in tandem. The real-time translate model handles over 70 input and 13 output languages with almost zero latency. Then, the whisper model powers highly tunable responsiveness across 80 input languages. And the main engine itself, GPT Realtime 2, brings GPT-5 class reasoning directly into voice. This allows for incredibly controllable expressiveness, like you can literally instruct the model to sound excited or even to whisper. Now wrap your head around this number, 128,000. That represents a massive 4x increase in the token context window for GPT Realtime 2. For you builders out there, this translates to roughly an entire hour of continuous back-and-forth interaction without ever having to truncate your system instructions or lose the thread of the conversation. It vastly increases the intelligence and the instruction-following capabilities of your agents. And equally as impressive is this, 200. The Whisper model operates at an incredibly low 200 millisecond latency. Honestly, this is the secret sauce. It's what makes live products feel instantly responsive. It allows for much earlier function calling and creates an ambient, real-time context that reacts in the blink of an eye. All right, moving right along to Section 2, the prototype, building voice search assistants. To see what you can engineer literally right now, let's look at an e-commerce prototype from our sources called SupplyCo. In the old days, we were stuck with waterfall tool calling. It was sequential, it was slow, executing just one action at a time. But parallel tool calling completely changes the game. An agent can now simultaneously execute 15 to 20 tools at once. We're talking checking the Seattle weather, reading one-star tent reviews, and adding items to a cart, all in the exact same moment. And this leads us to a crucial new concept called voice-to-action. This defines workflows where the model silently operates a visual user interface via tool use. And this is key, only speaks when specifically instructed to. Think about a product manager dashboard. In the SupplyCo demo, an agent investigates an activation drop-off for footwear in Europe, specifically on mobile Safari. It filters data, compares timeframes, and isolates the bug on the visual dashboard, all without constantly talking back to confirm every single click. It behaves exactly like an analyst in the loop. So how do you actually build your first voice-powered search assistant? It really boils down to these three simplified steps. First, define your UI tools. Give the model access to all your specific filters, buttons, and external APIs. Second, inject context. Feed it the mock data or real-time analytics it needs. And third, execute parallel calls. The model is going to reason across all these multiple inputs to update the visual UI simultaneously right as the user speaks. Which brings us to Section 3, the real world, handling noise and interruptions. Because let's face it, when pristine lab prototypes meet real-world chaos, things get messy. As Ken Murphy from Sierra puts it, voice is pretty unforgiving. Think about it. In text, a typo is fine, whatever. But in voice, a half-second pause or a compounding spelling error by an AI can strand a customer or even cancel the wrong flight. And trust me, nobody wants to be the developer on call for that incident. The stakes are incredibly high. And this brilliantly illustrates the reality of production audio. Voice agents don't get pristine studio environments. They have to handle highway noise, crying kids in the background, and aggressive customer interruptions. They even have to figure out how to correctly ignore human back-channeling, when we naturally say or aha while someone else is talking. But by utilizing this new voice-to-voice architecture, teams like Sierra are tackling this daily, achieving up to 200% faster P90 latency compared to cascaded systems. They're maintaining top-tier performance even in the face of total chaos. So to handle this chaos yourself, here are some highly actionable pro tips. First, you absolutely must tune your custom voice activity detection or VAD models specifically to your environment's noise profile. Second, you've got to understand when to utilize semantic versus server turn detection. But here is the most clever trick of all: dynamically disable VAD on specific turns. If your agent needs to read a required legal disclaimer like "this call may be recorded," you can actually disable VAD so an impatient user literally cannot interrupt the model until that legal requirement is fulfilled. It's just a brilliant blend of AI and compliance. Finally, let's jump into Section 4, the scale, managing context beyond 1 hour. Look, even with a massive 128K context window, what happens if a call accidentally drops or an enterprise session just goes super long and exceeds the API time limit? You followed this exact 3-step procedure. 1. Save the session state religiously. 2. Start an entirely new session. And 3. Rehydrate that new session with the saved context. Because you have 128,000 tokens to play with, you can push all of that previous hour's history right back into the new session, and the caller will honestly never know the difference. And so, the crucial point here is this final orchestration pro tip. Context management isn't just about restarting dropped sessions. It's also about managing live context. You can use the conversation item create function to inject background tool call results completely asynchronously. An async supervisor can review a call, grab database info, and just silently inject it into the model's memory while the model is still speaking or thinking, all without accidentally triggering an unwanted vocal response. It's a massive developer secret. We have covered a lot of ground today, from the deep, multimodal architecture of GPT Realtime 2, all the way to handling the messy reality of screaming kids on a highway and managing complex async database logic. The technology is simply no longer the bottleneck. That old cascaded lag is completely gone. The voice-first wave is absolutely here. So my question to you is this: armed with these technical best practices, what will you build? Get out there and start engineering the future. Thank you so much for joining me on this explainer, and I will catch you on the next one.